So in this video, we're going to talk about algebraic thinking in solving math problems. The problem states, Amy began with 5 marbles for every 3 marbles that Tara had. Amy began with 5 marbles for every 3 marbles that Tara had. What does this mean? We're going to look into this. And after Amy gave 1 marble to Tara, Amy ended with 3 marbles for every 2 that Tara had. So because of this change, Amy gave 1 marble to Tara. Now Amy ended with 3 for every 2 that Tara had. Before it was 5 for every 3. The question asks, how many marbles did Amy begin with? So what is algebraic thinking? Algebraic thinking is nothing but translate the relationships that described in this problem in English sentence into mathematical equations. And in doing so, we introduce variables to represent quantities that will appear in an equation. So in this problem, the relationships that describe, there are really 2 relationships. One is before the change. So if we think about the state, there's a state of before Amy gave 1 marble. This is before, and this is after. And this change is because Amy gave 1 to Tara. But the key to this problem is we need to understand what does it mean that Amy began with 5 marbles for every 3 marbles that Tara had. This means if we divide Amy's marbles into groups of 5, for every group 5, there will be a group of 3 Tara has. So if I call this Amy, this is Tara's pile. If I divide into groups of 5 for Amy and divide group of 3 for Tara, then we can make this 1-to-1 correspondence. For every 5 Amy had, there will be 3 that Tara had. 1-to-1 correspondence. And so on. And it will be exact number matching, which we don't know that number, but we know that they are matching. Okay? For every 5, there's every 3 that Tara had. So now let's think about the variable that we want to introduce to solving this problem. So the question asks, how many marbles did Amy begin with? And often it's a good idea to use one variable to represent the answer to the question. So let's assume A is the number of marbles Amy began with. And T is number of marbles Tara began with. Then from this relationship that Amy began with 5 marbles for every 3 marbles that Tara had, as we see that's really established this 1-to-1 correspondence between Amy's group of 5 with Tara's group of 3. This really means that, okay, let's using not capital letter, a small letter T to represent number of marbles Tara had. It's A divided by 5. This represents the quantity of how many groups of 5 that Amy's marble divide into equals T over 3. So this really represents this English sentence. Amy began with 5 marbles for every 3 marbles that Tara had. Now by the same reason, after Amy gave 1 to Tara, we have A minus 1 divided by 3 equals T plus 1 divided by 2. So first, why there's A minus 1 and T plus 1? Because after Amy gave 1 to Tara, what's left for Amy is A minus 1. At the same time, be careful on this, Tara had one more, so it's t plus 1. And the relationship of ended with 3 marbles for every 2 marbles that Tara had, it's the same thing. If we divide Amy had now into a group of 3, that will be exactly equal Tara had now divided into a group of 2's. So you have a minus 1 divided by 3 equal t plus 1 divided by 2. Now we have 2 equations. This a divided by 5 equal t divided by 3, and a minus 1 divided by 3 equal t plus 1 divided by 2, which capture the whole thing, the whole information that this problem had. We basically translate this English relationship into 2 mathematical equations. Now left with is how we solve this. So first, let's put those 2 equations together so it's easier to see. A divided by 5 equals t divided by 3. And then a minus 1 divided by 3 equals t plus 1 divided by 2. And we put a bracket, meaning that a and t are going to satisfy both equations at the same time. And often people put equation number to the right so that it's easy for you to refer back if you need to. So we have these 2 equations, and I'm going to show you briefly how we solve it, because the steps of solving linear equations is a topic on its own. It's probably going to take a lecture or even more. But here I'm going to go through briefly. So the basic idea of solving a linear equations is you want to manipulate equations. And the basic idea of manipulating equation is you want to do the same operation on both sides to simplify. So let's see. I'm going to multiply 15 both sides because we usually don't like fractions so much. If we multiply 15 both sides on equation 1, we get 3a equals 5t. And equation 2, multiply 6 both sides, we get 2a minus 1 equals 3t plus 1. Pay attention to those brackets, parentheses here, because as you multiply 6 on both sides, for example, on the left side, the 3 cancel each other, the 2 is left, but the 2 is multiplied to a minus 1 as a whole. So you have to have this bracket. Now, for this new equation, let's multiply the constant into the bracket so that we can put together the variables and the constant at the same time. 2a minus 2 equals 3t plus 3, and which is the same as by adding 5 both sides, you get 2a equals 3t plus 5. Okay, so we have these 2 new equations, 3a equals 5t, and 2a equals 3t plus 5. Now at this stage, there are in general 2 ways of solving this. One way is by canceling the t, called elimination. The other way is by a substitution. Both ways in theory is really the same thing, and people often have a different preference of which way to do. In here I'm going to be using substitution. So we want to solve a, right? How many marbles did Amy begin with? So we can replace the t. So from equation 1, we know that t equals 3 over 5a by dividing by 5 both sides. And now we know t equals this a, and we replace the t in the second equation so that the t is gone. And we're left with 2a equals 3 times 5, 3a plus 5. Now we multiply 5 both sides, we get 10a equals 9a plus 25, so that a equals 25. As I said here, solving this linear equation actually takes more practice and requires probably one or more lectures on the basic operations, the basic ways of doing it. But here, this lecture is really more focusing on how we translate a problem with English sentences into mathematical equations by introducing variables to represent those quantities that are in the problem, and changing those relationships in English terms about those quantities into mathematical equations. So here we have, before Amy gave 1, we know that for every 5 marbles Amy began with, there are 3 marbles Tara had, and that can be translated into this relationship of A divided by 5 equal T divided by 3. And once you get that, the second equation is more or less the same. A different way actually with seeing this, to capture this relationship, 5 marbles for every 3 marbles, you also can using a ratio to capture it. It's really A over T equals 5 over 3. Some people prefer write this, but of course this and this are really equivalent. And this is for this lecture.